My dear professionals, welcome to HydroCalc, your ultimate tool for all your pump selections. I know that you have been working with pumps day in and day out, and you have a lot of challenges within you, and it depends on the project how much is the challenge. Here with HydroCalc, we would love to streamline your pump selection by not undersizing or oversizing, just optimizing. Hi, I am Balaji Ganesh with over 25 years of experience working with pumps. So, I'll take you through this calculators and tell you all in one place calculator. And if you have this one tool, it will definitely save you a lot of time and money. So let me just take you through this calculator and show you what all we can do. And this is how the front page looks like. I will just show you what all you can do with this, what are the calculators which are available, and then I'll take you through one or a couple of calculators for you to have a feel of how easy it is to use, and then you can get in touch with me anytime to have a full demo or the full any queries that you have. So I have the first one, the residential water demand calculator, as well as the non-residential water demand calculator. You can determine what is the peak demand when you're working in a hotel or a hospital or any project by using NBC, National Building Code, British Standard, or Uniform Plumbing Code, and I have all the four calculators here. The most important is the pipe size calculator, and this is very important when you're working on an industrial project. So I'll take you through that. And we have the specific speed calculator, which will give you what is your characteristics on the suction side and whether you have a situation if it is abnormal or it is normal. So you can decide that by using the specific speed calculator. Then the most important thing is the friction loss. I have given you both Darcy and Hassan, and I'm sure you know what is the difference between the two. Just to give you maybe for your academic interest, Hassan is one where you use for water supply projects and long distance water supply and other things. But if you want to be very specific, and then you use Darcy, I'm just saying it from the application point of view. Then we do have a pressure tank volume calculator, which is very much needed when you're working on a hydropneumatic system or any other project which needs water transfer also needs a pressure tank. So you can calculate what is my pressure tank volume that I need for my project. The most important you can have is the NPSH available calculation, and I would request each one of you who are here to do this calculation for all your projects, be it positive section or negative section. Because if you don't take care of this, it is very expensive to correct it later. So that will be my advice, to use this NPSH calculation and be clear. The rainwater dewatering, yes, how much of what should be the capacity of my pump? Then for that you need to know how much of water I'm going to get, how much of rainwater I'm going to get, how much of the rainwater I need to dewater. So you can do all these calculations using the rainwater calculation, and also the wastewater which is going to come out of any premises. You can do that. You can do the hot water demand. You can calculate the BKW for all the pumps. Then you have the cold loop chiller pump selection, how many AHUs you have. Just put in the AHUs and you will know what is the right pump that I need for all my AHUs put together. Then for the boiler feed, what is the pump I need to have for my boiler feed. The most important, which everybody would like to know if you're working on something or you want to change something, is the life cycle cost and the payback that you will get. So you can also do that. We also have a carbon emission calculator. If you're working on sustainability and other green projects, then you would like to have what will be the carbon emission from my pump. So you can also do these calculations, and also you can calculate what should be the flow rate through the nozzle. I have 4 or 5 nozzles, and you know the diameter of the nozzle and the pressure that is required for you. You can calculate what should be the pump size. So this is in brief all the calculators that you have in one place. I'm going to take you through some one or two calculators to just give you an idea about it, for which I will just take an example. So I am going to take an example of this. You can see, like, this is a villa project that you're working, and I have taken how many washrooms and how many things are there, and I have put everything here. And they have 8 2 bhk, 8 3 bhk, and 8 4 bhk. And what are the total units that you will have? Now if I want to calculate what is the peak demand and what is the hydrodynamic pump that I need to size for this building, it's very simple. We will go to the calculator, and probably I'll use BS, and I'll enter. There will be a wash basin, which is 72 in number, and WC system, which is 72 in number, and a shower, which is 72 in number. But when you take such a project, then you definitely will have the bidet, so you can put your 72 here. Then you will have a kitchen sink, which is 24, because you have 24 units there. And definitely you will have more wash machines, so that will be 24, and dishwasher can be 24. I think that's more than enough for this building. And just say calculate, and here you have it. The peak demand that you need to size your pump for is 21.6. Probably you can do 3 pump system, 2 working, 1 standby, however you want to, but that's it. It's just a very simple tool which you can make use to calculate most of your complicated projects. So once I do this, I'll also explain a few things about this in the calculator. Is that I have given a reading supporting material, so you can go through the supporting material and see why you need to do and how you can do it. And you can give your project reference. For example, I will take it as project 1, and then you can have the date here, which will of course be the current date. Then you can upload a logo, your logo. So what I'm going to do is I'm going to upload my logo here. So I'll just load it, and there you go. So now this document is something that you can keep for you, and you can have it for your records. And you can also save this document and send it to your clients. For that, what you need to do is just save as PDF, and I'm going to save it in my desktop, so that I can show you how the PDF. I'll save it as the download one on my desktop and save. And now let's go to my desktop and see how much you go. And this is the PDF that you can see and how it is. So this is what you get, your document, and it is very neat. So you can have your records, and you can also send it to your customers. So once we go there, let's get into the project. I'll clear this. I'll return to home. I'll just show you one more is, I'll go to the pipe size calculator, and now we know that what is the peak demand. You can read my supporting document on why you need to do correct sizing of the pipe. And then you put your project reference, go upload your logo, and we know that it is 21.6. And I'm selecting a diameter of 3 inches, and it is for pressure boosting. It is 1.32, which is very less, so I need to go for a 2.5. And it's 1.89, which is a perfect velocity for me. So I'll go with a 2.5 inch pipeline if I have to pump 21.6. So that's very easy, as you can see. So same, you can save it as a PDF for your records. So now I'll clear it, and I'll return home. And I'll also show you the NPSHA calculation. Like, I have given the critical importance of NPSH, so you can go through it for your academic interest. Put your project name, and everybody likes to know what it is going to be for negative section. And now let me take this project as in mean sea level, which means it's 0. I'll show you what happens if we are doing the same in some other location. Probably I would have calculated using my Darcy, which is the friction loss is 3, and probably the 35 ambient temperature. Suction lift, because it's a negative suction, say let's have it as 3 meters. I advise zero 0.5 as a safety margin. Now you just calculate. you get it like 3.57 is the NPSHA required. Now you can refer to the document of the pump supplier and find out if this condition of NPSHA is greater than NPSHR. If this condition is satisfied, you can go ahead. You can also see if I change it to positive, then I should get my results here. You can calculate and it is 9.57. And suppose it's the same condition, negative, and I calculate, I get it here. And I'm working at an altitude, say, for about 610. Then my barometric pressure changes, and when you calculate, 3.5 has become 2.8. So this calculator has taken into account all the scenarios which you will be subjected to, so you can do your proper calculation. As I told you earlier, NPSH available calculations are very much needed, and please do it even if you are working with positive suction, so that you're clear, because correcting NPSH available is a very expensive process. So that's an advice that I will give. And if you want to know more about it, probably I'll be uploading a few videos. So I'll clear and I'll return back to home to use another calculator. So like this, you can go on and on with these calculators, and of course you can use all the calculators to finish any project that you have. So thank you for listening to me. And if you at all, if you want to download this software, it is priced very competitively, and I'll leave a link below in the description. And you can also contact me if you have any queries. And this is the contact. You can have the mail ID is pumpXpert28 at the rate gmail.com. I'll be happy to support you for any queries that you have. Meanwhile, I will appreciate if you can help me by downloading this, so that I can come out with more and more easy tools for you to optimize in your selections. So thank you very much for your patience and listening. Please do support me by downloading this software. Thank you so much, and I hope I'll get email from you. And also, I'll leave the link down below, so that it comes takes you here to this landing page, and you can straight away go to the download button. And there is a light version and an advanced version. The advanced version is the one which gives you a lot, all the engineering calculations you can do. And if I am adding a few small calculators like this, you will get it at free of cost. And this is a one user one license, and it is a laptop or a desktop model. And I have not done it yet for the mobile application, but soon I will be doing it later. So that is all about HydroCalc, and see you again in another video. Thank you so much.